This is Miss Plant's video in which I'm going to explain moments, levers and gears for AQA Physics GCSE in 5 minutes. So you know about forces. Forces cause objects to move. They cause them to change their motion. Normally it's acceleration, deceleration, changing direction. But forces, if set up in a particular way, forces can sometimes cause an object to turn. So as in, if you've got a force acting on an object that is fixed, then that object can turn. And the fixed point we call a pivot, sometimes fulcrum, but pivot. And that will cause this object to turn. And this turning vector of a force is called a moment. Moments can be clockwise if they cause the object to turn clockwise, anti-clockwise if they cause the object to turn anti-clockwise. And we can calculate the moment using this equation that you need to learn. Moment is equal to force times distance. Moment gets the symbol capital M. Force, capital F, distance, lowercase d. Force is measured in newtons, meters measured in distance, and the moment simply gets those two units squished together, and a moment is measured in Newton meters. It's not abhorrent if you find moments in Newton centimeters or something like that. That's not the end of the world, so long as the distance is measured in, so long as it's consistent with what the distance is measured in. Now, the thing about this distance is quite important you understand that the distance needs to be the perpendicular distance from the pivot to the line of action of the force. As in this one, it's quite straightforward because the line of action of the force is perpendicular to the blue line, which is the distance. And so the distance is simply the distance between the pivot and the force. However, if you had a situation like this, where the line of action of where the kind of lever, if you like, is not, or the blue line is not actually perpendicular to the pivot, then you need to remember that the distance is the perpendicular distance between the line of action of the force and the pivot. They like to trick you on this in exams by giving you a range of values. They might give you this value, this value. It is the perpendicular distance from the pivot to the line of action of the force. Now, the principle of moments is, you might get questions where they just ask you to use that equation. More likely, the principle of moments. The principle of moments is the idea that if an object is balanced, the clockwise moments about a pivot will equal to the total anti-clockwise moments. So say this example here, you've got some guys on a seesaw. You don't see seesaws anymore. I think they've been declared too dangerous. This guy's anti-clockwise moment plus this guy's anti-clockwise moment, if it's equal to this guy's clockwise moment, then this seesaw will be balanced. Right? So you add the moments up, doing the force, in this case it would be the weight of the people times the distance from the pivot, and then they should be equal on both sides if the thing is balanced. Typical GCSE question, they'll give you something balanced like this. This is a hanging mobile. You've got the masses of the objects, you've got some of the distances, and you need to work out the missing distance. So if you've got the mass, don't forget you need to use weight is mass times gravitational field strength. Gravitational field strength is about 10. So the weight of this, the force of this is 70, the weight of this is 10, the weight of this is 20. So then I can calculate the moments on this side because I know all the values. So the moment of this guy is 10 times 1 is 10 Newton meters. The moment on this side is 20 times 3. Don't forget I have to add those together, which is 60 Newton meters. So the moment on this side, if it's going to balance, must also be 70 Newton meters, 10 plus 60, meaning this distance here has to be 1 meter. Yeah, it's not drawn to scale. That doesn't matter. Right. The last bit on this is levers and gears. So a lever and a gear are things that are force multipliers. So you put in a smaller effort, you get out a bigger effort. You put in a smaller force to get out a bigger force, and they also are things that transmit the rotational effect of this force. Levers typically have a load, a pivot, and an effort. This is a typical example of a lever, and you can see that the moment on this side is 100 Newton meters. The moment on this side is also 100 Newton meters. So if I put a little bit more effort in here, so say 10.1 newtons, I push down on that, I can actually lift this heavy load of 100 newtons. It's worth saying though that I will exert my force over a longer distance, whereas this will only go up a little bit, but I'm still multiplying the force. They're not always quite like this. Sometimes you can have the pivot before the load and the effort, such in a wheelbarrow, but again, the effort is still further away from the pivot than the load, so you get that force multiplier effect where you put in a smaller effort to be able to lift a bigger load. A gear. Gears basically work on moments as well. So we've got a small gear here. The pivot of the gear is the center bit. The distance is the distance there to the edge, the radius of the wheel, and then you've got a force acting. I apply a force on this wheel, which will then turn this bigger wheel. The idea is this force can be smaller and I get out a bigger force because I've got a bigger distance here. So a small gear will turn very, very fast. So this gear will have to turn around several times, whereas this gear might only turn around once. So a small gear turns very fast to get a small moment, but a big gear turns around really slow and you get a bigger moment out. So you're kind of multiplying the force. That's it.